Hello, and welcome back to Brigham Young University Hawaii's online economics course. Today we're talking about Chapter 5, Elasticity, a measure of response. As a start, I'd like you to think about elasticity in a unique way. It says elasticity because you can compare it to a rubber band. And you know, when you pull on a rubber band, some rubber bands are really tight, hard to stretch. Some rubber bands are very elastic, much easier to stretch. That's what elasticity is. In the previous chapters, we talked about supply and demand, how supply and demand respond, or how our quantity demanded or supplied responds to changes in price. We never really put any specific numbers to those. So in this chapter, we're going to put some numbers to them. This chapter is an explanation of how much quantity demanded or quantity supplied responds to changes in price. And at the end of the chapter, we'll talk about how they respond to changes in other things. But let's review what we're going to talk about in this chapter. We're first going to start out by talking about the elasticity of demand. And the learning objectives here are we want to make sure that we can explain the concept of price elasticity of demand and its calculation. Second, we want to explain what it means for demand to be price inelastic, unit price elastic, price elastic, perfectly price inelastic, and perfectly price elastic. Third, we need to make sure that we can explain how and why the value of price elasticity of demand changes along a linear demand curve. Number 4, we want to try and understand the relationship between total revenue and price elasticity of demand. And number 5, we're going to try and make sure that we discuss the determinants of price elasticity of demand. So let's get started. First of all, the price elasticity of demand is nothing more than the percentage change in quantity demanded of a particular good or service divided by the percentage change in the price of that good or service. And we continue to use the caveat of everything else stays constant. So the equation is nothing more than the percentage change in quantity demanded over the percentage change in price. And what we're trying to understand is how responsive is the change in quantity to a change in price. Some things are more responsive. We call those elastic. Some things are less responsive. We call those inelastic. And we'll talk about some variance in between. Let's give an estimate of how we would calculate elasticity. We're going to start by this idea called arc elasticity. It's nothing more than the measure of elasticity based upon percentage changes relative to the average value of each variable between 2 points. This is probably the easiest way to calculate elasticity. And what we typically use is we use this delta symbol to reflect change. So in this case, change in quantity divided by the average quantity. And so you may have two numbers, and it may be change in quantity goes from 1 to 2. So the change in quantity from 1 to 2 is just 1, and you divide it by the average quantity, or the average of 1 and 2, which should be 1.5. So that's how that equation is used. This is an equation you're going to need to memorize. It's an equation you're going to use many times in assignments and on exams in this course. It's called the arc elasticity. It's derived again by taking the change in quantity divided by the average of those two data points over the change in price divided by the average of those 2 price points. Fairly simple. Now, if you were to look at a demand curve, we can pictorially lay out what it means to discuss elasticity. So on this side, we're going to make a pictorial representation of the responsiveness and how it impacts demand. This is a graph that has the price per ride in an amusement park on the y-axis, and on the x-axis is the quantity of rides demanded in thousands. What you can see in point A is you have a situation where at 80 cents per ride, you're going to demand 40,000 rides at the amusement park. Then we have at point B, at 70 cents per ride, you're going to demand 60,000 rides at the amusement park. And what we're going to try and illustrate is this concept of elasticity. So movement from point A to point B shows that a 10% change in the price changes the number of rides demanded per day by 20,000. At a different point in the curve, you can calculate different levels of elasticity. So the point that we just mentioned, which is at the point here at the top, we calculated an elasticity measure of 3.0. Now you'll notice that there's a minus sign in front of it. Typically we ignore the minus sign because we understand that the minus sign just represents a negative relationship between price and quantity, which is the law of demand. Remember, that is, if price goes up, quantity demanded goes down. That relationship is signified by the minus sign in front of the 3. But this point here, which reflects a decrease in the price from 80 cents per ride to 70 cents per ride, has an elasticity measure of -3. Later down the curve, you can see that the elasticity measure goes from a 3 to a -1. And then down here, we'll actually even have a lower elasticity measure of 0.33. So along any demand curve, you have periods where the elasticity measure is larger, then it becomes equal to 1, and then it becomes less than 1. And we're going to discuss those, but what this typically means is any elasticity measure that is greater than 1 is considered to be elastic. Any elasticity measure that is equal to 1 is considered to be unitary elastic. And any elasticity measure that is less than 1 is considered to be inelastic. Using different language, we would say that since this is elastic, that it's very responsive to changes in price. At this part of the curve, since it's unitary elastic, it's really unresponsive. And this is a point where it's less than unresponsive, it's negatively responsive. Another relationship we want to talk about, which we'll do quickly and then we'll give some examples of it, is this idea of total revenue. Now, total revenue, for those of you who are accounting majors, is a fairly easy concept to remember. But for those who aren't accounting majors, all you need to realize is that most firms have at the top of their income statements the line called total revenue. And all total revenue is the price of the good that you're selling times the quantity or the number of goods that you're selling. That's your total revenue. That's the total amount of money that you bring in from your customers. It's the firm's output, which is the quantity, multiplied by the price at which it sells that output. We talked about price elasticity. It refers to the situation in which the absolute value of the price elasticity of demand is greater than 1. That was in the top part of our demand curve that we just saw. That's the part of the demand curve where things are elastic, things are responsive. That's an elastic part of the curve. There's a unitary price elasticity, which refers to a situation in which the absolute value of the price elasticity of demand is equal to 1. And then you have an inelastic part, which is non-responsive. An inelastic part refers to a situation in which the absolute value of the price elasticity of demand is less than 1. Now remember, we showed these points on the curve, and now we have it illustrated with this is the elastic region of the demand curve. This is an inelastic region of the demand curve. And this single spot right here in the middle is unitary elastic. And every demand curve has periods like this on it, and some are different than others, but in general you can assume that every demand curve will have elastic regions, unitary elastic regions, and inelastic regions. Now let's talk about how total revenue and price elasticity relate to one another. Let's talk about the elastic part of the demand curve. What you'll notice is that if there's an increase in price, it reduces total revenue. Now think about that. Elasticity, or an elastic part of the curve, we said is very responsive. And we know that if prices go up, quantity demanded goes down. And so if here we have a situation where there's an increase in price, what happens to total revenue? Well, in an elastic part of the curve, an increase in price will cause a decrease in quantity demanded, And since revenue is price times quantity, that's going to cause a decrease in total revenue. Similarly, a reduction in price goes down, is going to cause an increase in total revenue. Again, if price is going down, quantity demanded is going up. And since revenue is price times quantity, that's going to cause an increase in total revenue. Now, what happens at the inelastic part of your curve? At the inelastic part of your curve, an increase in price causes an increase in total revenue. And why is that? Well, think about it. Now we're inelastic part of the curve, which means it's unresponsive. In other words, changes in price do not cause changes in quantity. So now we have an increase in price, but our quantity didn't change because we have an inelastic part of our curve. So since our quantity didn't change and revenue is price times quantity, we raised price, so we're going to increase total revenue. Now, a similar thing happens when you reduce prices. You reduce prices, but again, you're at an inelastic part of your curve, which means quantity demanded is not going to change much, so a reduction in prices causes an equal reduction in total revenue. Now, at the unitary part of your curve, in other words, your elasticity is 1, you can increase your prices. There will be no change in total revenue. You can reduce your prices. Again, there will be no change in total revenue. So let's talk about what a perfectly inelastic curve looks like. Now, perfectly inelastic, it's totally insensitive to price changes. There is no responsiveness here. It refers to a situation in which the price elasticity of demand is 0. You also have situations where it's perfectly elastic. In other words, it's perfectly sensitive to price changes. And that refers to a situation in which the price elasticity of demand is infinite. We'll give some examples there. If you were to look at this, this is a perfectly inelastic curve. An easy way to remember this curve is that it's sort of shaped like an eye, up and down eye. Perfectly inelastic. An example of a perfectly inelastic good would be something like cigarettes or drugs. Because it doesn't matter what happens to price, you're not going to change your behavior. You're addicted. Anything that we're addicted to tends to have inelastic behaviors. Price changes go up for heroin. Heroin addicts are still going to find a way to pay the price and consume the heroin. It works similarly for alcohol. It works similarly for cigarettes, marijuana, and other drugs. These are perfectly inelastic goods. Now here's a perfectly elastic curve, and the easy way to remember which way it goes is it's sort of shaped like one of the legs that come off of an E. It's perfectly inelastic. What that means is that, great, we consume at this price of $5, we consume all the quantity, but what happens if we change the price to $6? We consume nothing. And if we change the price to $4, we consume nothing. Okay? At $5 is the only price that people will consume. And there's not a lot of goods that behave this way. But there's some other examples of price and elasticity graphs using the proxy for your demand curve. And this is a fairly commonly looking one. And this is a shorter version of one. But you get all sorts of shapes and sizes of demand curves. And the shape of these curves is very important to understanding the elasticity. In other words, the responsiveness of these goods to changes in price. So let's talk about substitutes. Let's talk about a few other issues that tend to be determinants of elasticity. Availability of substitutes is probably the most common one. You could say that Lucky Charms as a cereal is fairly inelastic, partially because there are no substitutes. There's nothing as good as Lucky Charms, and if you don't buy Lucky Charms, you don't eat. And that makes it fairly inelastic. What happens to the elasticity of demand for Lucky Charms if somebody makes a Lucky Charms that is similar to, not quite as good, but pretty close? Maybe it's called pseudo charms. Now you can actually eat the Lucky Charms from General Mills, or you can eat the pseudo charms. Does the availability of a substitute, the pseudo charms, change the elasticity of demand for Lucky Charms. And indeed it does. Let's think about it. Now you have Lucky Charms, you have pseudo charms. Now you raise the price of Lucky Charms. Is it as inelastic as it was before the substitute came into being? No, it's more elastic now. More responsive. Because if I raise the price of Lucky Charms, I'm likely to go over and buy pseudo charms because they're almost as good as Lucky Charms. And the closer and closer those substitutes become to the real thing, think about Corn Flakes as an example. You have Post and you have Kellogg's Corn Flakes. They're almost exactly the same. The closer those substitutes are to one another, the more elastic their behavior is. So the availability of substitutes significantly increase the elasticity of products and services. If there are lots of close substitutes, goods to choose from, consumers can switch easily. It makes things more elastic. The importance in the household budget is another issue that it determines the price elasticity of demand. So think about this. What is more elastic, purchase of pepper or the purchase of gasoline? Gasoline is very important in a household budget because you drive to work every day, you drive to school every day. So if the price of gasoline goes up, are we more inelastic or more elastic? Consider pepper. You buy pepper maybe once every 6 months, once a year. So if the price of pepper goes up, do we change our behavior? Not really. We still need pepper, and we don't really notice how much pepper costs. If you were to ask the average person, how much does pepper cost? They won't know. However, if you were to ask the average person how much gasoline costs, they would know. So the larger and more important a good becomes as a percentage of a household budget, the more elastic it is. So the price of a good relative to your total income impacts the elasticity. Time is another interesting one. In the short run, it's difficult to find substitutes. In the longer run, things become more elastic. In the short run, if gasoline prices increase, I'm not going to be able to go and sell my truck, sell my SUV to get a car that is more fuel efficient. In the long run, I can do that. So time impacts elasticity. The longer the time period, the more elastic. The shorter the time period, the less elastic things are. Now let's talk about responsiveness to demand to other factors. The learning objectives in this section are, number one, we need to explain the concept of income elasticity. Remember, in the past we talked about price elasticity, how responsive is quantity demanded to changes in price. Now we're going to talk about income elasticity. In other words, how responsive is demand to changes in income. Number two, we're going to classify goods as either normal or inferior depending upon their income elasticity of demand. Number three, we're going to try and explain the concept of cross-price elasticity of demand and how it's calculated. And number four, we're going to classify goods as substitutes or complements depending upon their cross-price elasticity of demand. So let's proceed with this section. Okay, so let's go ahead and get started. Remember how just a few minutes ago we talked about price elasticity, or in other words, the responsiveness of quantity demanded to changes in price. Now what we're going to do is we're going to switch that up a little bit. Now we're going to talk about income elasticity of demand. In other words, what is the responsiveness of demand for changes in income? So income elasticity of demand is the percentage change in the quantity demanded, in other words, the responsiveness of demand, at a specific price divided by the percentage change in income that produced the demand change. So all we're saying here is, what is the change in quantity demanded with change in income? Now remember from our previous chapters, we talked about how an increase in income causes most goods to increase in demand. So if I all of a sudden start making more money, I'm typically going to buy more Lucky Charms. I'm going to have more money, I'm going to buy more things. So an increase in income causes an increase in demand. With income elasticity of demand, we're just asking the question of how much. We do this by saying what is the percentage change in quantity demanded, just like we did in the previous one, but in the denominator, instead of saying percentage change in price, we're going to say percentage change in income. And so what we're trying to figure out is just how much does quantity demanded change when we have a change in income. Okay, let's take a few examples. If we consider DVDs, and we consider that really they're normal goods, and all a normal good means is that as income goes up, quantity demanded goes up. And so what we're going to see, just by way of example, is an increase in income causes an increase in demand. And that's pretty common. A decrease in income causes a decrease in demand. And that's the way normal goods behave. Inferior goods, remember that's an example of Lucky Charms versus pseudo charms. Pseudo charms are the inferior good. So in an inferior good, an increase in income causes a decrease in demand. So think about that. I'm thinking about pseudo charms. They're close to Lucky Charms, but not quite as good. But if I have an increase in income, I'm going to buy fewer of my pseudo charms, and I'm going to buy more of the real thing, more of the Lucky Charms. So pseudo charms are an inferior good. An increase in income causes a decrease in demand for pseudo charms. At the same point, if all of a sudden we go through a period of recession or I lose my job, a decrease in income, I move away from Lucky Charms because they're a little bit more expensive, and I move towards the inferior good. I move towards the pseudo charms. So a decrease in income causes an increase in demand of the pseudo charms. And those are just the basics of normal and inferior goods, which we've talked about before. Let's talk about cross-price elasticity of demand. Okay, this is the percentage change in the quantity demanded, like we did before, but it's going to be a little bit more specific. Percentage change in quantity demanded of good A, and this is the good that we're trying to measure, divided by the change in price of good B. This is called cross-price elasticity. We want to know if the change in the price of butter reflects the quantity demanded of margarine. Okay, these are two goods. I want to know, does the change in the price of one good affect the change in quantity demanded of another good? That's called cross-price elasticity. And elasticity just measures the relative responsiveness of the quantity demanded of good A when we change the price of good B. So let's take a look at what happens here. So this is a normal good or an inferior good. In the case of a normal good, an increase in the price of B causes an increase in demand for good A. A decrease in the price of good B causes a decrease in demand for good A. Similarly, an increase in the price of B causes a decrease in demand for good A, and a decrease in price of good B causes an increase in demand for good A. This we've talked about previously in our discussions on supply and demand, so that should be fairly straightforward. Let's move on to the price elasticity of supply, and then we'll be towards the end of this discussion section. Learning objectives here are to make sure we explain properly the concept of elasticity of supply and how to calculate it. Number two, to explain what it means for supply to be price inelastic, unitary elastic, elastic, and perfectly inelastic and perfectly price elastic, similar to what we did for demand. Then we're going to explain why time is an important determinant for price elasticity of supply, similar to what we did for demand. And we're going to apply the concept of price elasticity of supply to a labor supply curve. So let's get started here. So price elasticity of supply is precisely the same as it was for demand. We just changed supply for demand. So price elasticity of supply is the ratio of the percentage change in quantity supplied of a good or service to a percentage change in its price. We leave all other things unchanged. The equation is fairly straightforward. Percentage change in quantity supplied over percentage change in price. Now, let's take a look at how this works in the apartment rental market. And the concept that we want to illustrate in this graph is just one of changing elasticities. You here see demand curve 1. So this is our demand for rental units. Here's our supply curve 1, our supply for rental units. Now, as the supply curve increasingly points upward, we call it inelastic. As the supply curve increasingly points downward, like this, we call it more elastic. So this curve moving from S1 to S2 is going from being relatively more inelastic to becoming relatively more elastic. And a curve that is more elastic is more responsive. So understanding the shape and nature of curves in the rental market, for example, is very, very important because we start to see that things become increasingly more elastic. But what we're also seeing is that our equilibrium prices based upon elasticity change dramatically. So here is our supply curve 1 in demand condition 1. And what you see is this is our equilibrium price. Supply curve 1 intersects demand curve 1. Well, what happens if demand increases? So if demand shifts from here to here, we're still on S1. Well, this is our new equilibrium price or rental price for property. And this is our new equilibrium quantity. And that's in a relatively inelastic market for supply. But what happens if the market starts to increase its elasticity? And this happens over time and at various other conditions. What happens is our new equilibrium price and quantity change from being here to being here. So changes in supply elasticity dramatically affect where our equilibrium is going to lay out. So this is an example, like we had before, of supply elasticity or supply that is infinitely elastic. This is an example of supply that is infinitely inelastic. So supply is perfectly inelastic. Now, let's talk about time. Now remember we talked about this in the previous example and we said, look, when you're thinking about demand, think about it from being a consumer. When you're thinking about supply, think about it from being a producer. So if I were to think about demand elasticity, I'm thinking about how responsive is my elasticity, or how does my elasticity change my quantity demanded. I'm thinking about that from being a consumer. In supply, I'm thinking about it from being a producer. In other words, I own the company that makes these particular goods or services. So let's talk about time. In the short run, supply is likely to be inelastic or non-responsive to changes in price. So if a change in the price of the good that I'm making, call it Lucky Charms, the price for Lucky Charms goes up. Think about it from being a producer. My supply is going to want to go up, isn't it? My price goes up, my profits are going up, I'm going to want to produce more. So quantity supplied is going to shift to the right. The market's going to expand. However, in the short run, the size of your factory is fixed, the size of your supplies are fixed. So in the short run, it's relatively inelastic in response. You can't make your plant bigger in the short run as a response to higher prices. So short run, supply is relatively inelastic. In the long run, supply is more elastic because remember, if I all of a sudden am now experiencing higher prices for Lucky Charms and I'm producing Lucky Charms, I'm going to want to go out and acquire more wheat, more marshmallows. I'm going to want to acquire a larger plant so I can make more Lucky Charms. That's a long run response. In the short run, I can't really change all those things. What I can do is use the resources that I have to produce a little bit more and use the plant that I have to produce a little bit more. But still in the short run, I can't change all those variables. So in the short run, supply is relatively inelastic. In the long run, supply is more elastic. Sounds sort of consistent to what you would have expected in the law of demand. Okay, let's talk about selected elasticity estimates. And what you'll see is this is fairly interesting. In terms of price elasticity, food is very elastic. In other words, here you have a measure of in excess of 2 as an elasticity measure for food. Now this is in the long run, because in the short run you don't really change a lot of your behaviors. But in the long run, food is very elastic. So in the long run, if prices for food go up, we change our behavior. Our responsiveness to price changes is significant. And that's reflected by the fact that you have an elasticity measure that's greater than 1. Okay? Beer is relatively inelastic compared to food. So if we change prices for food, we would expect that we're going to respond to those price changes. If we change prices in beer, not so much. If we change prices in heroin, it's unitary elastic. There's not going to be a lot of change in response. If we change prices of Coke, this is Coca-Cola Coke, it's fairly responsive. Why? Because we can move to Pepsi. So where you have a substitute for Coke and Pepsi, if you change the price of Coca-Cola, your elasticity measure is 1.9, so it's fairly elastic, then you're going to move to Pepsi. Likewise, Pepsi's a little bit more elastic, so Pepsi can't really afford to change their prices or to increase their prices, because why? Well, people will immediately go to Coke. Gasoline, as you can see, is more elastic or inelastic. Well, it's less than 1, which makes it inelastic, and this is in the short run, because in the short run, if prices for gasoline go up, do you change your behavior? Do you stop driving to work? No, you do. You still go to work. Do you stop going to school? No, you still go to school. So your behavior doesn't change, especially in the short run. So gasoline has an elasticity measure of less than 1, which makes it inelastic. And it's inelastic because there are just things you have to do with gasoline, and you can't change the quantity of gasoline that you purchase very easily. In the long run, however, transportation is very elastic, has an elasticity measure greater than 1. The reason why is in the long run, maybe we say, okay, we'll stop driving. We won't drive, we'll take the bus. Or we'll ride share with our friends. So in the longer run, we can make those changes and decisions of how we do things and make things more elastic. I hope this section has been able to enlighten you a little bit on responsiveness, elasticity, how we change our behavior based upon changes in prices. And if you have any questions, please feel free to email me and let me know what your questions are, and I'll get back to you as promptly as I can. Look forward to moving forward with you on the next chapter.